Welcome back, everyone. We're still in section 1.4, and in this video we're going to talk a little bit more about evaluating functions. So my goal is for you to be able to evaluate functions using expressions in this video. So let's talk a little bit about what I mean with this, and let's just get right into an example. So for this whole problem here, I'm just going to say we'll define a function. I'm kind of getting tired of f of x, so I'll just use h of x, not really that important. And this is going to equal 1/2 x squared minus x plus 6. And your goal is to do what's called evaluate the following. So the first one I want you to do is h of -2. Now, -2 is just a number, it's not an expression, so hopefully this is relatively straightforward. If you were showing your work on this, you'd say, okay, h of -2 is, well, there's 1/2. I'm going to put -2 in for x, and then I'm going to subtract -2, and then I'm going to add 6. I was trying to make this a little bit difficult, so be very careful with your negative signs here. I know sometimes we tend to forget them. So we'll follow PEMDAS. -2 squared is actually 4, so 1/2 times 4. Minus 2 turns into +2, and then +6. And so if you do all that, you should get 2 + 2 + 6, so you should end up with 10. Alternatively, you could have just plugged all of that into some sort of calculator, and it should spit out the number 10. Hopefully I'm correct. Okay. So not so bad. Hopefully that was just kind of a review from the previous video. Here's where it might get a little bit hairy. We'll see what happens. So now what I want to do is h of 2x plus 1. Notice I'm not saying multiply h of x by 2x plus 1. There's no multiplying going on here. We're actually going to replace x in this case with the expression 2x plus 1. This is what's called an expression. Here's where I kind of spent a lot of time on symmetry. This is why, because you're going to be doing a lot of replacing x, or this is one of the reasons why. So hopefully this won't seem too terribly bad, at least at first. We'll see what happens as we go on. So first of all, I want to point out that this is the answer here. You would say h of 2x plus 1 equals 1/2 2x plus 1 squared minus the quantity 2x plus 1, and then plus 6. I want to pause and just point out that this is the answer. This is the concept that we're applying right now. You're plugging in an expression for x. You did it. That being said, we can actually reduce this answer a little bit and make it look a bit nicer. So usually what I'm going to have you do is multiply everything you can, and also you're going to want to combine like terms. So mathematicians, or I guess math teachers, often just say the word simplify here, and I don't really like that word because it doesn't always make sense in context. But in this case, when I say simplify, here's what I'm saying. I want you to multiply everything, and I also want you to combine like terms. Okay. So let's take a little aside here from the problem. So I'll call this aside. I will come back to the main problem, but I want to focus on 2x plus 1 squared for a moment, just to remind you how to do this. You need to make sure to take 2x plus 1 and multiply it by itself. If you try to distribute the squared, you're wrong. So again, this is kind of, I'm stepping up on my pedestal here and saying what's wrong. I'm not going to do this every single time, but just because this is still kind of new, you might get 2x squared plus 1 squared. This is wrong. Please don't do that. I'm going to put some more x's through it because that just really looks awful to me. Okay, anyways, back to the actual problem. So we do 2x plus 1 times 2x plus 1. You go like this, right? You multiply it, you distribute those numbers to each of the other ones. Sometimes this is called FOIL, which is fine. So I get 2x times 2x is actually 4x squared. 2x times 1, another 2x times 1, and then 1 times 1. So I end up with this. By the way, this is fine if you want to organize your work this way. I'm very happy if you say something like an aside and you kind of show me your work. And then you can say back to the problem if you want. It really helps if you kind of outline this when you're doing problems. So back to the problem, we now should have h of 2x plus 1, I'll just kind of remind everyone where we were, is 1/2. I figured out what 2x plus 1 squared is, so I'm going to replace that. And then I haven't done anything yet with the rest of this. All right, so we're now going to distribute, so I'm going to take the 1/2 and distribute it to each of those. I'm going to take this -1 here, or negative sign, and I'm going to distribute it to each of those. So I now end up with 1/2 of 4x squared is 2x squared. 1/2 of 4x is 2x, and then 1/2 of 1 is just 1/2. I'm going to subtract 2x, I'm going to subtract 1, and then I'm going to add 6. Okay, let's find our like terms. 2x squared is on its own. I do have I do have a x and another x, and then I also have some stuff with no x's here. So we're going to go ahead and combine all of those. Like I said, the 2x squared is on its own. It's good. 2x minus 2x. Ooh, those cancel. That's kind of nice. That's just 0x, so that's gone. And then 1/2 plus 6 minus 1 negative, so it's plus 5.5, which is 11 over 2, or you could write it like this. I prefer fractions whenever possible. It makes the answers just a little bit cleaner, but that would be my answer. Okay, so we just evaluated this function using an expression. Okay. Let's do another one, and I'm actually going to do a couple things with this one. So we'll have a new function a of w now. Instead of x, I'm going to use w. I'm going to call it 8 minus 3w. And so I realize I'm doing AB, so I'm going to change my notation here just a little bit to be consistent. So this is just a new example. Okay, and I'm going to say evaluate. So let's go ahead and first practice. Let's do a of 3w minus 1. So if you were doing this problem for me, you'd start off by saying a of 3w minus 1, 8 minus 3, and then you're going to replace this with 3w minus 1. Once again, this is the answer. The rest is just going to be kind of simplifying and making it look a little bit better. But I want to point out that this is the answer, and this earns quite a bit of points on any problem if you first do this, because this is the concept I'm really testing. Okay, now we're going to simplify. So I'm going to distribute the -3 to each. So I'll have 8 minus 9w, and then I'll have a -3 and a -1 gives me plus 3. Combine the like terms, I'll have 11 minus 9w. And I might even change this into sort of the standard form we're used to with the variables first, although this is not a necessary step, and so that would be my final answer, -9w plus 11. Okay. For the next one, I'm going to do something a little bit strange. I'm going to do a of w, and I'm going to bring in a new variable, which I'm just going to call h. H just represents anything right now. It's not really anything in particular. And then I'm going to subtract a of w, and then I'm going to divide the whole thing by h. So this actually has a special name when you bring h's in like this. This is actually called the difference quotient. And if you ask any pre-calc student about the difference quotient, they'll probably say, oh yeah, I know about that. Because, sorry, not pre-calc, calculus student about the difference quotient. This shows up in calculus a lot. It's kind of the whole point of calculus is to do stuff with this. So you're going to get some practice now so that when you get to calculus, you can actually do more with it. Okay, so here's what you're going to do. First of all, let's figure out what a of w plus h is. So this was 8 minus 3 w plus h. Let's go ahead and kind of simplify this. Okay, so there's a of w plus h. A of w, well, that's already done. That's just this right here. And h is just h. So now let's put it together. A of w plus h minus a of w all over h equals, I'm going to take this part first, and I'm just going to put it in parentheses to kind of keep it organized. Like this, and then it's all over h. So I took that and put it there, and I took this and I put it here. Okay. All right, let's do some work here. The parentheses in the beginning don't really matter, so I can just kind of ignore those. 8 minus 3w minus 3h. This does matter. I'm going to have to distribute, so I'm going to have minus 8 and plus 3w all over h. Now, whenever you have these division problems like this, keep in mind there's kind of an implied parentheses around the numerator and the denominator. So you can't just choose and start canceling, because it's very tempting to do this and just be like, oh, that's gone, look, cool, it's great. But the problem is this is currently in the parentheses, and so you can't just do that. So don't do that, you're wrong. It's called home wrecking. We have a happy home in the numerator, and that h down there just wrecked it, so please don't do that. Okay, back to the problem. The 8 minus 8 over here, that's 0. Negative 3w plus 3w is 0. So I'm actually left with negative 3h over h. Now you can cancel it, because this is all being, it's negative 3 times h here, and then we're dividing by h, so I can just do h divided by h, and that's actually 1. So then I'm left with just negative 3 times 1, which is just negative 3. And so that would be my final answer. And that takes us to the end of